A citation can be present and still prove nothing. Citation precision and recall expose unsupported claims and missing evidence. You'll learn how the pieces fit into a workflow that audits citations against sources and separates unsupported from missing support. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. RAG systems often stitch together claims from retrieved documents and a generator. The pain isn't just hallucination. It's the illusion of being grounded. An answer can list sources and still rest on claims those sources don't actually justify. Engineers need a way to tell two very different failures apart: citations that point to the wrong place and claims that have no citation at all. Intuitively, precision asks, of the citations given, how many truly match supporting documents? Recall asks, of the claims that had supporting documents available, how many were cited correctly? We'll turn that intuition into a small, inspectable workflow that produces both numbers and a simple fail label for each answer. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now we will build a tiny dataset that represents claims, the citations the RAG system attached, and the human or evaluator support data. This snippet builds the smallest useful data shape for claim-level citation evaluation. The practical problem is that an answer-level citation tally hides which claim each source was meant to support. Claims holds each claim, its ID, and the citation attached by the RAG system. Support records, which document IDs, actually justify each claim, a compact stand-in for human judgments or a review set. The initial print simply reports how many claims exist and how many attempted citations are present, so you can confirm the input is ready for stricter scoring. We saw the raw shape, but we still need to turn claims into explicit verdicts, so metrics are meaningful. The next step inspects each claim and classifies its status. This example separates two failures that look very different in production. A cited claim can still be wrong if the attached source does not support it, while an uncited claim may be missing evidence entirely. Label inspects a claim. If cite is absent, it marks it missing. Otherwise, it checks whether the cited document ID appears in support, and marks it supported or unsupported accordingly. Labels applies that rule to every claim, so downstream metrics are based on claim-level evidence rather than citation presence alone. The output makes clear that C2 has a citation, but that citation isn't actually supported. Exactly the false grounding this scorecard is meant to catch. Now that every claim has a verdict, we need numbers that mean different things to different teams. One metric should catch false trust, another should catch missing references. This code turns the verdicts into two metrics with different meanings. Citation precision asks, of the citations the answer gave, how many were actually supportable? Citation recall asks, of the claims that had support available, how many received a correct citation? Attempted, needed, and supported. Keep those denominator choices explicit, so engineers avoid a single, vague citation score. In our small example, the answer loses precision because one citation is wrong, and it loses recall because one supportable claim went uncited. The output prints both scores together, making false trust and missing evidence measurable separately. For release gating and dashboards, you often need a single label per answer, so reviewers can triage quickly. That label should reflect the worst problem in the response. This snippet gives the evaluator a stable answer-level label without throwing away the claim details. Rank explicitly ranks verdicts, so unsupported citations are treated as more severe than missing ones. Unsupported citations can falsely make an answer look grounded. Max picks the worst verdict present, and fail name converts that numeric rank back into a human-facing label. The result shows the answer labeled unsupported, which directs teams to debug the most dangerous failure first, instead of just counting citations. With a single labeled answer working, we can scale this into a tiny batch scorer that preserves the claim-level facts while giving per-answer statistics. This example turns the pieces into a tiny baseline scorecard for a batch of RAG answers. Instead of evaluating one response by hand, Answers groups claims under answer IDs, and the loop computes the same outputs for each item. Labs preserves claim-level verdicts, OK counts, supported citations, and the precision and recall slots in card keep the two metrics separate so you can see both failure modes. The failure label uses the same rank policy as before, keeping the batch report consistent with the single answer view. The output confirms 2 answers were scored and shows that A2 is clean, proving the baseline can distinguish good citations from risky ones. In a real project, you would tie this scoring to your retriever and to human judgments on a representative subset. The same logic maps to a QA dataset, where each question has claim-level annotations, or to a customer support corpus, where each assertion must be rooted in a policy document. What we built in 3 quick points. It's a claim-level verifier that separates unsupported citations from missing citations. Use it when you care about trust and when answers may list sources that do not actually back their claims. One caveat: it depends on accurate support annotations, so noisy labels will distort both precision and recall. To take this further, tune your retriever top K and reranker threshold so the candidate set contains the real supporting document more often. That change directly lifts citation recall and gives the system a chance to show accurate precision. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.